Do you know, if you wanted to open up a new data center in West London, when you could get a firm grid connection?
2035, I think it is.
2037.
2037, right.
So what are we doing? Not only are we wasting incredible amounts of money, but we've got a city which is incapable of attracting the most important segments of business.
It's 2024, nearly 2025. You've got 5 years, you've got 100 million, and you've got £100 billion problem.
If you talk about how much it would cost to decarbonise London, what about how much it can save to decarbonise London? You know, there's incredible amounts of money being wasted, Michael, on wasted energy, wasted demand, wasted light.
Hello, I'm Michael Liebreich, and this is Cleaning Up. Now, every analysis since the mists of time has said that if we're going to get to net zero, 50% of the heavy lifting has to be done by energy efficiency. So you would expect energy efficiency to get 50% of the attention, 50% of the money, 50% of the political capital, and so on. But it doesn't. Why not? Well, partly because it's seen as boring, but also it's complex, it's hard to monetize, and some people think that it's pointless because the Jevons effect absorbs all of the benefits, but principally because it's boring. Now, my guest today would beg to differ. It's Jonathan Maxwell, CEO and founder of SDCL, that's Sustainable Development Capital LLP, back for his third turn in the hot seat. Now, for disclosure, I've been an advisor to SDCL and to Jonathan's team for a few years, and I'm glad to announce that SDCL is joining Cleaning Up as a member of the Leadership Circle. Jonathan is also the author of a book called The Edge, and the subtitle is How Competition for Resources is Pushing the World and its Climate to the Brink. Now, a quick apology. I'm here at SDCL's offices in Mayfair, London. There might be a little bit of building noise at various points during the episode. But please join me in welcoming Jonathan Maxwell for the third time to Cleaning Up. Jonathan, welcome for the third time back here on Cleaning Up.
Thank you. Huge accolade. Thank you very much, really, for having me back on.
A pioneer in everything you do.
Try to be.
Let's start with your book, The Edge. Why did you write it? And what did it say? But give us the short version.
Well, to avoid the long version, which was 15 years of working out what's wrong with the energy system and what to do about it, which is actually another part of the subtitle. I wrote it in 2022, or began writing it in 2022. The world changed. Russia invaded Ukraine. My argument is it invaded Ukraine largely driven by competition for resources, specifically natural gas. We'd seen by 2022 huge increases in climate manifestation driven also by natural gas, oil, and use of other fossil fuels. So the book was really designed to draw the thread, join the dots. If you're going to compete for resources, it's going to create competition for resources. Competition for resources creates climate change and conflict. And, as I'm sure we'll discuss today, that's something we can do something about. And that's a lot of what the book is about. It digs deep into the energy sector. It breaks it down. It unpacks it. It reveals the enormous levels of waste and inefficiency associated with the way we use stuff, not just energy, but food, water, and proposes ultimately that if we look at the world different and we apply a lens of efficiency to everything that we do, we can make a massive difference to how the world works.
Now, the first time that you came on Cleaning Up, the episode was called Cheaper, Cleaner, More Reliable.
Yeah.
And, you know, I sort of associate SDCL and your work with this drive really for the cheaper is very important. Yeah. Of course, cleaner. So it's kind of cleaner is the given, cheaper is the real drive. And then the reliable was sort of, I don't want to say tacked on, but I don't associate it, you know, back then with you know, why you got into all of this. Is the book a response to that kind of more reliable, i.e. more resilient, less conflict? Is it a response to changes in how you see the world?
I think availability and reliability had been something which Europe wasn't really worried about up until 2022. Now, America had been worried about it for a long time. It was worried about it largely because the grid keeps getting interrupted with catastrophic impact for health, industry, society in general. Why, though? It's the weather, usually. We know, not actually, ironically, in a country that's grappling with dealing with climate change philosophically, it's very prone to natural disasters. But Europe, so it always thought about energy, what I would call energy security, Michael, because it had to. Like, how do you get energy to work 24/7, even if the grid goes down? So the US has become actually pretty good for purely practical reasons with energy availability security. Europe was asleep at the wheel up until 2022. Nobody cared. Nobody talked about energy security. I was writing papers for the Atlantic Council, January 22, talking about the vulnerability of the European energy system and, frankly, the entire economy. Wow, 2022 was a big year. To February, Russia invades Ukraine. March, the gas taps turned off. Boy, did people care about energy security. So you're right. 2022 was the turning point, fundamental handbrake turn in the way that Europe, at least, and then ultimately the rest of the world needed to think about energy security. Of course, how am I going to deal with that leads to two other massive issues. There's cost, and then in today's world, there's the climate and nexus. And of course, that's where it all comes together. Energy, environment, climate, and economy all merges. And that's really what the book is about.
So we're going to come back to the question of cost. Is it really cost or is it investment? Because those two are different things. The funny thing is that in the origin story of new energy finance, when I decided to start that back in 2004 and was thinking about it in 2003, the question of resilience was actually a really big one. It was a big part of why I did it. And the reason was I was traveling, I was in Brazil, and there were rolling power cuts because their energy system hadn't kept up, as there were in places like South Africa, of course, as well. But also we had a big power cut in the US. Do you remember all of New England went out? Because of kind of weather was the trigger, but the problem was not weather, it was underinvestment. Mm-hmm. But Europe also had a big power cut. We also saw that power cut that cascaded, I think, from Switzerland through into Italy, and it took out, and it was a lack of awareness of resilience issues, which I think on the electrical system, Europe actually did a good job fixing. So you look at how Ukraine war starts, and within a few weeks, they synchronized Ukraine to the European grids.
On the power
Incredible performance. Absolutely. I mean, that's a story that needs its own book. But you're right. We got lulled into a false sense of security, particularly Germany, because of the availability of cheap Russian gas, which was, of course, a deliberate strategy by Vladimir Putin.
So while we've known each other for pretty much that whole period of time. I think I met you 2006-ish. 4, 5, 6. When you were doing that, I was at HSBC. I was buying your research to try and figure out what was going on in the world. But it's also because I was coming back from China at the time. And China had got energy availability, in fact, resource security at the top of its mind. So if America and Europe didn't, the Chinese government did. Why? Because energy was a big problem. Supplying energy for a rapidly industrializing country, a massively urbanizing country. But there are also massive environmental issues. For example, that's what led to Beijing having to figure out that they needed to plant trees to stop dust blowing in from the Mongolian desert. For example, they needed to fix the waterways transport systems. And it's also why China from 2006 wrote things like the medium-term economic plan to fix this, to secure international supply chains, which has led to them basically owning the supply chain for the clean energy revolution today. But they also did other things like focus, as we'll talk about, I'm sure, later, but on productivity and competitiveness and how do I use energy better, more efficiently. And so, but it's absolutely right. It really started the story from a security perspective. I think what's happened is the big questions about how you do that cost effectively. I think that's obviously dominated the $9 trillion that's been spent by then on renewable power on the grid. But it's also raised a very big question, which is an even bigger question that I look at every day, which is, are we imagining the solutions right? Everything, Michael, about how to try and deal with energy security that we talk about normally is about power, even this point about Ukraine. But power, being more specific, electricity is a very small part of the world's energy system. Indeed, it's 20% globally. It's about 17% here in the UK. It's about 15% in the United States, right? So I think when I think about energy security, it's not just electrons, it's molecules, it's the ways of moving everything around. And those are the three major challenges: security or resilience, and then cost, and then, of course, the mega one of carbon.
I'm glad you brought China and China's, sort of handbrake turn around 2013, 14, and focus on the green economy into this, because, we've now, whatever we are, 120 episodes into this, 180 episodes into this, there's an episode on that. And in fact, we had an extraordinary guest, Dr. Ma Jun, kicked off, amazing. I think it was season 11 or 12. We'll put a link in the show notes. And what was so fascinating is he had the exact same epiphany as you, which was driven by the air quality in Beijing, the air quality in China. His epiphany was, we got to do something about this and it will create wealth. And it was the same epiphany. We had another guest, Lauri Milivirta, coming at it more from the activism side, trying to spur change from that side, had the same epiphany because of the same smog problems. But let's come back to, are we thinking about this right? Because I first want to kind of look at how the world has changed. I think what we're saying is a big change is much more focus on resilience, right? But we're also in a very different interest rate environment from where we were when you first came on the show and money was essentially free, and you second came on the show and we were in the middle of this, the war had driven up this inflation spike, gas prices, but also coal, oil, everything. Money was expensive. And now, what are you seeing? Is the world returning to a kind of new normal, or what's happening on that front?
If I put that into context of where I started the business in 2006-07, we were not in a zero interest rate environment. In fact, when we started raising capital from institutional investors 10, 12 years ago, we were not in ZIRP yet at that point. So in a lot of ways, the cost of capital today is comparable. I think there are some different types of risks, but the cost of capital is comparable to where I started my journey 10, 15 years ago. Okay, so what's changed? Some of the costs of delivering, for example, renewable power have completely changed. Great. But the cost of capital, obviously today are relatively steep. We've seen $9 trillion, as I said, invested in clean energy and the grid, which is fantastic. We've seen every time it's COP coming up in a couple of weeks' time, every time I've gone to a COP since 2007, 8, it's got bigger and bigger and bigger. I think 60,000 people when you and I were in Dubai last year.
84,000.
84,000.
Yes, 84,000. Yeah.
So, okay, so those are all the good things that have changed, but otherwise not a lot. Okay, so we've still got the same amount of greenhouse gas emissions happening every year. We've still got, roughly speaking, 80% of the world's energy is oil, gas, and coal. For all of the excitement and passion and well-meaning associated with wind and solar, it's still a tiny proportion of the world's energy supply. Even only in the United States, 10% of electricity supply today, primary energy, is coming from renewable power, so from wind and solar, that is. So, that's wind, solar, and other forms of renewable energy all combined. Actually, only 10% of electricity, about 8% of the total energy economy. So I think what I'm really driving at is, in a way, nothing much has changed, but yet the urgency of dealing with this problem, hasn't gone down. It's gone up, right? We've got global population increases. We've got higher problems with energy security. Here in Europe, the cost problem is worse than people really focus on or imagine. It's very often, I don't know, maybe everybody I'm sure listening to this podcast understands, but in Europe, we're paying 2 to 3 times as much for our electricity as America. We're paying 5 to 6 times as much for our gas as America. So if we're thinking about Europe, which broadly has the same GDP as America, as a competitiveness and productivity story, it's a disaster unless we do something about it. Now, as Europe imports energy, America exports energy. We have to look at the world as it is, not necessarily we want it to be. We're going to continue. And energy dependence in Europe is going up, not down. Exports from America are going up. UK, do you know how much of our energy we import in the UK? We sort of I celebrate the Labour government's idea that we could be a clean energy superpower and energy independent. But do you know how much energy?
We're a net importer.
76% of our energy. In fact, energy dependence has been going up recently, not down. So I think that what I'm really saying is what's changed is barely anything, and what needs to change is we need to actually look at how much of the energy, which is such an incredibly important part of our security and cost and carbon story, not just in Europe, but in America, how much of the energy are we using efficiently? Or putting another way, how much are we wasting? And that is it's the biggest, dirtiest secret of the energy sector.
It's the secret we keep revealing episode after episode. Let me just say that I am more optimistic, well, not more optimistic. I'm more positive about what has been achieved in terms of the percentages that you quote there for the percentage of electricity, the percentage of clean or renewable power.
I want more of it. I think
but so where we are is the numbers are 17% of all electricity globally is renewables excluding hydro.
Yep.
If you add in hydro, you get a much bigger number. And electricity might be a sort of small part of final energy. But remember, final energy is things like petrol you put in the tank of your car. Right. It's not the motive power of your, that you use to actually drive.
Yeah.
So, where I'm going with this is what I call the primary energy fallacy, which you're sort of restating, even though I know you know all about the primary energy fallacy, which is that the denominator that's always cited particularly by people who want to tell us that the problem is too big and we should do nothing about it, the denominator, primary energy demand, and it's usually the IEA figure that's used, is nothing to do with demand. So it's the same conclusion as you make. It's not demand. That is actually supply. That's how much coal we shovel, how much gas we take out of the ground. They're all about supply. Yeah. So it's called primary energy demand. It's the biggest trick the devil ever played, calling that demand, because it's not.
Can I talk about demand then?
Oh, absolutely, yes.
I'd like to talk about demand because A, I agree with you, but B, I'm afraid it's not the best story on the demand side either. So I'm very dull in the summer. At the end of July every year, the UK government produces statistics on how energy is produced and used, like a sources and uses table.
The famous Dukes.
Digest of UK energy statistics. Yes. It's my summer reading. Jilly Cooper when I retire. In October, finally, in October this year, I don't know why it was delayed this year, the Lawrence Livermore National Laboratory have produced the update on how the US...
And that's the Dukes equivalent for the US.
It's been running since the 1970s.
It's the Sankey diagram, correct. The famous one, which you're right.
A good old energy security crisis in the 70s created a piece of work which has been going on 50 years now, which is looking at how energy is produced and used in the United States. And actually, this is the bit I enjoy looking at the most, how much of it's wasted. But a good example, I'm just going to focus on this point about primary energy fallacy, because I completely agree with you. What you're talking about is you look at all the sources of energy and you have to look at all the uses. And actually, if you don't think about the uses, you're missing pretty much the whole point. But just to give you a stark idea about the latest numbers, because we haven't spoken about this, we haven't seen each other this month. Residential in energy demand in the US represents about 44% of the energy that goes into residential is electricity. Pretty big. About 50% on the commercial buildings in America run on electricity. Of course, we know the rest of it's natural gas for heating and the rest of it. In industry, it's 13%, 13%. You and I know the reasons. You need high temperature process heat, you need sort of gas, oil, various other, but it's 13%. And in transport, the number is actually 0. just to be really clear. And transport energy use in the US is a very, very, very big part of it. Transport energy in the US is just nearly 40%. It's actually 37% of all end use of energy in the United States. So electricity is nowhere. Industrial, where it's only 13% of energy use, is actually 35% of all end demand. I'm not talking about primary energy. So the biggest use is industry and transport. And I'm afraid electricity is barely anywhere. Now, that's in the United States. There are other markets and economies and regions that are doing better and have thought about this. But I think I'm incredibly optimistic because as a business person, I think one of the biggest problems we've got in the world is how much energy we waste. Business is all about solving problems. So I think that's great. Got something to do for the next 20 years. But the second thing is, as an investor, I look for inefficiency. And we'll come on to how inefficient energy use is in transport and industry. But that makes me, as an investor, incredibly excited about it. Rather than this being boring, this is the biggest opportunity in the energy sector. And it's just as big, to make the point you made in the introduction, it's just as big as the supply side on renewable power, if not bigger.
But what that raises then is the question of whether we're looking at it the right way, right? Because you flip between the problem being that electricity is not used enough in heating and transport, which, by the way, I think is a fantastic opportunity. I agree, because we already have the solutions, right? Yeah. It's called a heat pump and it's called an electric vehicle. And if we just rolled those out, we'd solve, huge amounts of these problems. But we don't think of those as energy efficiency solutions. So what happens is we bang on about efficiency, and immediately everybody thinks it's all about lowering the temperature on your home and having to wear scratchy sweaters. And they think about it as being, improving some industrial process by 1 or 2%, right? And the biggest change that we can make is actually going straight for the primary energy fallacy, straight for the primary energy, and electrifying, right? Because I did the numbers, it's in my audio blog, the superheroes of the transition. I did the numbers for going from a incandescent light bulb burning coal to an LED light bulb on solar, and it's like a 95 or 98% reduction in primary energy, and almost nobody would think of that. The LED light bulb is energy efficiency, but electrifying with solar versus coal, nobody thinks of as energy efficiency, right? Heat pumps, you go from a gas boiler to a heat pump, and you can have a 78% reduction or an 80% reduction if the coefficient performance is good. And people think of that as a heat pump, not energy efficiency. And the same if you do a vehicle. You go from the same vehicle, electric versus internal combustion, 75% reduction in primary energy, but no one thinks of that as an efficiency move. So we're banging on about efficiency, but the real game is around electrification.
As long as the generation of the electricity is efficient.
Do you know what? Not even, because all these people who say, go to an EV and it's using coal. Australians, go on a bulletin board or on any social media in Australia, you'll be told EVs are a waste of time because they burn coal. And, even if you run your EV on coal, the electrical bit is so efficient, you will save emissions by going to a coal-powered EV. Right. So, and the heat pump, definitely, you could literally power in this country, take your gas boiler, put the gas in a power station, generate electricity, and use it to run a heat pump, and you'll reduce emissions. So it's not just the generator, it's the system. It's the system that has to change.
I think we've got to burst the thought bubble. So when people think about energy supply, which very often is about electrical supply, they think about a technology. I mean, you just mentioned coal as an example, which people would be horrified about, thinking that they'd be driving on coal. But you've given a practical case for why the end efficiency, the life cycle efficiency is better, right? But when people think, the thought bubble is very often around what good looks like. It's got to look like this. It needs to be hydrogen, and it needs to be a battery, and it needs to be a solar park or a wind farm. But you're absolutely right. If you don't focus on the problem that you're trying to solve, then you create another problem, which is creating a solution looking for one. So a great example, let's take nuclear or gas or frankly coal, and this is where we might disagree, I hate wasted heat. I hate wasted heat. Generally, on electricity generation in the UK and the US, generally about 55% of the primary energy, that is any type of fuel, whether it's natural gas, we don't use coal in this country, they do in the United States, or uranium, about half of the primary energy is just simply lost at the point of generation through heat rejection. Now, capturing that heat, high temperature, particularly high temperature heat, and using it for industry rather than dumping it into space is a radical transformation of the efficiency of supply, even, and you said it, using fossil fuels like natural gas or nuclear. And that for me has got to be part, not everything, it's not all of this or all of that, but it's got to be part of the way we radically rethink and burst this thought bubble. The first way is to start solving problems, not running around with solutions looking for them. And then the second way is to apply the lens of efficiency. You yourself have said that hydrogen is about 22% efficient when you try and turn it into power. That doesn't make sense. What makes sense is to try and operate the system at much higher levels of efficiency.
Hydrogen bingo. The first person who uses the word has to buy drinks. You lose, I win. But I don't want to go down the hydrogen rabbit hole, if I might, because you implied that I don't like saving or using waste heat. And I think it's more nuanced than that. I do absolutely want to use the waste heat, but you've got to even use waste heat in an efficient way.
Absolutely right.
As an example, if you take waste heat out of an industrial process at 150 degrees or 120 degrees, whatever, and you put it into district heating to heat homes to 21 degrees,
then you could cool it down.
That destroys exergy. That destroys the value, because energy has quality as well as quantity. Yeah. And so what I would like to do with a lot of industrial waste or unused heat, rejected heat from the primary process, is upgrade it back again to whether it's steam or heat, to the temperature that it's needed at. And so if you're rejecting heat, reject it at 20, 30 degrees, where it can go miles and miles and miles in pipes and doesn't lose much more, and where it then can be used, maybe upgraded a little bit more locally at the other end. But fundamentally, what we're doing is using heat at the temperature that it is, rather than, what drives me crazy as a thermo geek is the idea that you would burn anything, hydrogen or natural gas, at 2000 degrees. That's the flame temperature in a boiler or in a furnace. And you're doing that to heat a home to 20 degrees.
No, so
that is absolutely ridiculous.
But you can take that very high temperature heat at hundreds of degrees, or as you say, at thousands of degrees, and use it for industrial processes like pharmaceuticals manufacturing, or a high temperature process heat for other types of industry. That's one of the key things that we've done. I've done over the last couple of decades. It works. And you know what? 15 years ago, it was an idea, but it does work.
It works. But I guess my question would be whether it locks in, whether it kind of validates the idea. It tries to add value to a waste stream, right? And I think that a larger part of the answer needs to be not having the waste stream to start with. Just using, for instance, we had an episode with Alex Grant, who's producing magnesium through electrochemical processes. The episode is called From Mining to Brining, but actually it's about moving from baking rocks to get magnesium to an electrochemical process that's just inherently just doesn't produce all that waste heat that you would love to get your hands on because you can, use it for something. And I'm saying, why should it just not be produced?
I mean, great, Michael, but, I agree with you. In 30, 40, 50 years, I think we will, this is what the word transition means, an energy transition. We'll get off a lot of the traditional manufacturing facilities for energy, and we'll get on to more efficient ones that don't waste heat. But we're going to be generating a lot of heat using gas, nuclear, and other molecule type fuels over the course of the next 20, 30 years. And I don't want to sit around and watch half the world's energy go up into space.
That's a fantastic segue to the exact way in which you're not sitting around. What does SDCL do? Anybody wants the detail of the past should listen to the past 2 episodes, episode 14 and episode 113, where you've talked about it. But could you give us the thumbnail about how you, okay, those are the problems. We've done a deep dive. Fantastic. We sort of agree on, in fact, to be honest, a bit of manufactured disagreement. We agree, right? How do you make money from solving those problems?
So I think on previous discussions we've had, I've used 3 words: cheaper, cleaner, more reliable. Right? And at the end of the day, what's the opportunity? If you've got a massively inefficient energy system where so much energy is being wasted through extraction, generation, transmission, and distribution, you can find ways to solve that problem, right? So actually the edge, which is the name of this book, actually originally came from the fact that, if you translate Ukraine literally from Russian to English, it means on the edge. But the other thing it is a business term that I use, edge, which is efficient and decentralized generation of energy. So a lot of the solutions that I've been working on for the last 10, 15 years are decentralized generation. So instead of generating energy in the countryside and wasting the heat because nobody can use it, instead putting energy directly at the point of use. So what SDCL's done now over the last 10, 15 years is built about $2.5 billion of profitable projects which provide energy services directly to the point of use, right? So we generate those energy services through solar on site, through capturing waste heat from industrial processes and making power and steam back out of it by using even natural gas or renewable natural gas and using the power and the heat to provide energy services. So a lot of distributed generation, or in a nutshell, on-site generation for business, industry and transport. So that's the sort of supply side efficiency story that we've been building. We've now connected up to about 20,000 properties through our projects, but some of those projects, quite a few of them actually, isn't just about providing efficient supply, it's about reducing the amount of energy that the building needs to do the same work or the same job. So for example, it turns out that you don't need a 60-watt lamp. You need a 6-watt lamp if you switch it to LED. This is something we started doing 10, 12 years ago. We changed all the lights for Santander Bank, lots of car parks, lots of hospitals and so on. So you can invest capitally. How do you make money out of it? On the supply side, it's producing cheaper energy that's on site and more reliable for clients, cheaper, cleaner, more reliable. On the demand side, it's just making buildings work better, better lighting, better heating, ventilation, air conditioning. Problem, it costs money. Solution, that's what finance is here for. We can design and pay for basically the upgrade or the retrofit of your building, what do you want to say, and then actually spread the cost over the benefit so that ultimately it costs less to run your building than it did before. And that's a huge part of what we do.
So I think what's interesting is how many words you need to describe the thesis. And I mean, it's not a critique. It's just, I think that is part of the reason why energy efficiency just kind of, or all these discussions, they become complex. And fundamentally, I think what we're talking about is, you call it pricking the thought bubble. What we're really doing is just saying, what is the job we're trying to do? I want cold beer. I want lighting. I want an industrial process. I want the output of the process. And the pricking the thought bubble means focusing on the output, on the outcome, on the demand side, and then sort of so we're moving, instead of pushing energy into one end of the system, we're pulling a solution out. And then that solution is cheaper, cleaner, more reliable, and that then drives the business opportunity. Is that I may be using as many words as you, but it feels like it's that focus on pulling the solution rather than pushing the supply.
It's exactly right. It's basically focusing on what the problem is, right? And I think there's you can approach this either constructively or with outrage. I'm going to start with outrage, right, to start with. I don't think it's okay in this country, for example, that the biggest energy user in the country, which is the government, uses about 15% of all energy, wastes most of it. Now, the constructive side to that is that we could deliver energy, the UK could deliver energy to its public buildings, hospitals, schools, universities, government accommodation, even the Ministry of Defence, much cheaper, much more carbon efficient, and much more reliable and secure than the grid does. So that's the constructive side of it.
But you won't do that by running around with a hydrogen hammer looking for a hydrogen nail
Definitely
to hit,
not.
right? And you won't do that, but you also won't do that by, I've been involved in the review of energy market arrangements, REMA, which is all about pricing.
Yeah.
Is that a waste of time? I mean, how would you, because there's so much focus on the wholesale markets and energy supply, and Great British Energy is going to go off and do offshore wind, or it's going to go and do transmission. But what you're saying is the real problem is the government's estate is wasting energy throughout the system, in the government estate and presumably upstream. But if we look upstream, we probably won't solve the problem. Is that right?
I mean, you're going, actually what you're really talking about is narrative, right? What's the problem that we're trying to solve, right? Is it that we're trying to get as much solar power into the system as possible, or get as many heat pumps into the market? Honestly, that's mostly what I hear. There's not enough. The problem is there's not enough renewable power. There's not enough wind. There's not enough solar. There's not enough heat pumps.
Absolutely correct. Sorry to interject, but with the REMA process, we're talking about whether we should have locational pricing in the UK.
Yeah.
And the objection is, if we change the system, we won't build enough power. And of course, the problem that you're talking about is it's not a problem of building enough power. It's actually how we use it, and what are it's switching the narrative to the use, pulling the solution instead of pushing the supply.
Absolutely right. Just to unpack that point you made about the local pricing and how nuts, I think, objecting to these sorts of things is. You're absolutely right. If you're not going to look at the location, in other words, what the supply and demand characteristics are of a location, you're blind to one side of it, and you'll come up with a solution that isn't addressing the problem. A great example: if you have a very large amount of power generation available in a particular place, the basic thought bubble we need to burst is that the first thing people think about is, how do I get this a huge distance? I'm going to invest billions of dollars, pounds, whatever it is, to get it from here to wherever it's being used. Rather than, well, gee, we've got incredible amounts of power. Why don't you come and locate your industrial processes, your data centers, at the point at which we could actually generate this energy? So let's bring, and this is what I mean by distributed generation. I don't just mean, a whole sort of anarchic on-site power gen with windmills and floating down the Serpentine. What I mean is, let's actually locate industry use and demand in locations where it makes sense, cutting out incredible waste on transmission distribution.
We'll be back to continue the conversation with Jonathan Maxwell after this short break. Cleaning Up is brought to you by the members of our leadership circle. That is Actis, Ecopragma Capital, EDP of Portugal, Euroelectric, the Gilardini Foundation, KKR, National Grid, Octopus Energy, Quadrature Climate Foundation, SDCL, and Wärtsilä. For more information on the Leadership Circle, please visit cleaningup.live. That's cleaningup.live. If you're enjoying Cleaning Up, please make sure that you subscribe on YouTube or your favorite podcast platform and leave us a review. That really helps other people to find us. Please recommend Cleaning Up to your friends and colleagues, and sign up for our free newsletter at cleaninguppod.substack.com. That's cleaninguppod.substack.com. In the UK, what's bizarre is we're having this discussion about all sorts of things. Sweden is building green steel and data centers, and Scotland isn't.
Yes.
And nobody asks why.
Well, here's another amazing feature. Now you pull up Scotland, right? UK, I've been talking about renewable power as if I'm not passionate about it. I am. I'm passionate about it. As a Brit, I'm passionate about it because we've got about a quarter or so of the offshore wind resource of Europe. But what do we do with it, Michael? Right, so we've got about 5 gigawatts either, kind of coming online or online, let's say by the end of the decade.
Well, going from 12 to into the 20s, well, very quickly, yeah.
Right, but
gigawatts.
A lot of it's non-dispatchable. At the moment, we're wasting about 10% of all renewable power generated in the UK just because it's being curtailed. So this problem starts to get quite big. If you're getting 5 gigawatts of power gen and you've got 1 gigawatt of demand, what do you do with it? So the thought bubble is, well, let's just build power lines right across the country, have a great big argument with everybody about how much time, money and landscape it destroys. Instead, why not actually localize industry there?
The first thing we should be doing is dumping that curtailed power on Scotland and the North to draw, and they would all buy EVs and heat pumps, probably wouldn't even require subsidies.
But you are charging them on the basis of our system at the moment what Londoners have to pay for power.
100% we need to change that, 100%.
Right. So I agree with you completely.
Now, we've done what we always do. We've chased the topic and it's fascinating, but we were going into what does SDCL do? How do you make money, whether it's SDCL or frankly, anybody else, how do you make money? So what are the products or ways you do that?
So the company is called Sustainable Development Capital. We started 12, 13 years ago designing and investing in solutions to these problems, right? So the question was, if the problem we're trying to solve is that your energy is too expensive, it's too high carbon, and you may not be able to rely on the grid, how do we solve that problem? So to that point, we started with problem identification. Somebody once said to me, you don't want to be a solution looking for a problem. So we didn't set up ourselves as a solar developer or wind farm. We said, well, how do we solve those problems? So we started 10, 12 years ago building these systems that said, look, if you are a data center, Michael, and you are in East London, and you're worried about the grid availability, and you're worried about the cost, and you're worried about the carbon footprint, we'll design an on-site system that can cut costs and improve your carbon efficiency. It can power and cool your data center, so it's cheaper, cleaner, and more reliable than the grid. We did that in data centers. We did that wherever the problem arose. So it's just things like data centers, hospitals, commercial industrial facilities. In fact, broadly in the built environment, that's where the problem is. So over the years, that's what we've done. We've built this very substantial portfolio of on-site generation, which delivers energy cheaper, cleaner, more reliable than the grid to our customers. So the way that we make money out of that is that we design the project, we develop it, we pull everything that's needed physically together. That is the design, the construction. We then invest the capital on behalf of our funds in the construction of those sites and projects. We then benefit under contract from a contract with our customer. So the customer says it might be a data center operator or a hospital. The customer has certainty. The customer knows that as long as we're producing the energy, that's basically the power, the heating, cooling, they're going to pay us, our funds, a fixed amount broadly, as long as it's available. So it gives them price certainty. And our funds know that they're going to get broadly a fixed amount of return for the investment that they've made. So that's the way that we're doing it. It's an infrastructure investment process. It starts at concept, it goes through the development construction period, and then we own and operate these assets over their lifetime.
So the customer is getting heat as a service or light as a service or energy efficiency as a service and so on. The other customer, it's interesting that you very much locate the customer is the asset owner, the user of the heat, the light, whatever. The other customer, though, is the investor. Yes. And so those are the people who put the money into your funds. Yes. When you started, I know from previous episodes, you had to spend a lot of time educating them. What does a typical customer look like? And are they now smarter than they used to be? And are they frightened off by the letters ESG now, which perhaps 2 years ago they weren't? So
when we got started, actually, we had broadly a match between public and private sector money. So 2012 to 2014, our biggest investors, Michael, the first ones were governments. So we were the first discretionary investee manager for what was the Green Investment Bank back in those days in the UK. We set up a fund here to do energy efficiency. We did the same thing in Ireland, broadly in Singapore and New York as well. So government was a very important part of that story, but it always wanted to see private sector investment. But because the government was there, it was easier for us to raise capital from the private sector. That was insurance companies, pension funds. Since 2018, having said that, our funds have grown dramatically, 5-10x in terms of actual scale up of the business. And it's been much more private sector investors. So these are gritty institutional investors who are not investing, I would say, for ESG reasons. I think they get the biggest bang for the buck from an ESG perspective by investing with us. But the motivation is risk-adjusted return. It's investment performance. And that's what we've been focused on, which is saying, how can we invest the right stages of these projects, whether it's at the development construction phase or it's maybe buying an existing platform or operating asset and making it better. So it's insurance companies, pension funds, asset managers, broadly commercial institutional capital. Now, funnily enough, as it happened, having built up this platform, we've actually now been able to go back and start to partner with government again. So last year, we looked hard at what London's plans were to decarbonise, as an example. London, it's very difficult to put offshore. I joked about putting windmills in the Serpentine, but it's genuinely very difficult to put local power gen in London, particularly renewable power, given the land availability. So we looked at, if London wants to decarbonise by 2030, what can we do? And that's the story. If we can reduce the amount of energy that London's buildings, industry and transport need to do the same amount of work by applying the same efficiency principles that we have all around the world, we can make a big difference. So we went back to the London government. The London government, through the London Treasury, which is the Mayor's office, said, we will, if you will. So we did invest £50 million each to put together a new fund, which is called the London Edge Fund, which is designed to decarbonise London's buildings. So where does our capital come from? Look, it's commercial, institutional, what the Europeans would call market economy, investor principle. People are investing for financial return. But we're actually able to put that together in public-private partnerships and make big difference.
I'm going to jump on just one thing, which is the big difference. Okay. I mean, I think it's fantastic. And I think that because that was the stuff that I was pushing for when I was on the board of Transport for London. Yeah. And I think I introduced you at one point to some very senior people in the administration, the current administration, to try and help plug you in there. Yeah. That was some years. It's taken years.
Thank you.
But also, 100 million. I mean, the mayor going into the last election said that London would be, if you elected him, London would be carbon neutral, would be decarbonised by 2030. That was part of his pitch to Londoners by 2030.
It's a big ambition. Right, yeah.
It's a big ambition, which we know, and I know, would cost or would require investment of literally hundreds of billions. You just have to look out of the windows from any of the tall buildings in London, look across London, look at how much has to change, built environment, transport, almost none of which, by the way, the mayor owns or directly controls. And I mean, I love your London Edge Fund, but it's 100 million. I mean, here we are. It's 2024, nearly 2025. You've got 5 years, you've got 100 million, and you've got £100 billion problem.
So for us, it's owned within a 650 million euro fund. It's a great way for us to get things done in London. For London as a city, it's going to show that these things can be done. If you talk about how much it would cost to decarbonise London, what about how much it can save to decarbonise London? There's incredible amounts of money being wasted, Michael, on wasted energy, wasted demand, wasted lights. The National Health Service in the UK still hasn't changed its light bulbs. There's still 55% of their light bulbs. They've done nothing pretty much on on-site generation. So there's billions. In fact, if just the National Health Service changed its light bulbs, did nothing else, it would save £1 billion by the end of the decade and dramatically reduce its carbon footprint.
I wanted to stay with London because I don't know if I think
hospitals in London.
In 2015, I got very close to standing for mayor.
Yes.
And my pitch on climate was going to be, you don't need to believe in it. You don't need to believe that climate change is happening and that it's going to do this. Because Londoners, why don't we just keep 40-50% of all the money, which by the way is in the tens of billions per year, keep 40 or 50% of it more in the London economy by doing exactly what your Edge Fund
so you do
doing.
agree with me.
I do.
And I'll give you one other thing.
I just think it's minusculely too small.
It's just the tip of the iceberg, but you've got to get that because that's the bit that people see, Michael. So I'll give you another example. It's only a small part of what we want to invest as well, but it makes things happen. Having a partnership with the Mayor of London is very helpful. It obviously enables us to work much more constructively with the public sector, which is a big chagrin for me. I want to make big changes in that sector. But it's also an opportunity for us it should act as a beacon. It should just act as a trigger to get things done. A great example. It's not just that we're wasting enormous amounts of money in London by needlessly squandering energy inside buildings and with barely any on-site generation to solve that problem. It's not just the waste, it's the opportunity cost. So what do I mean? Do you know, I think you probably do because I've told you, do you know if you wanted to open up a new data center in West London, when you could get a firm grid connection?
2035, I think it is.
2037.
2037, right.
So that data center in West London, in East London, an edge data center right here in town, this is one of the most important economic stimulus that we could introduce into our economy. So what are we doing? Not only are we wasting incredible amounts of money, but we've got a city which is incapable of attracting the most important segments of business. So this is the other reason to do London Edge. It's just literally a little LED light bulb on the lighthouse, right? That's what we're trying to do. Just make it shine very, very brightly and say, this is the opportunity. It's not just about stopping wasting profligate waste of money I'm sorry to bang this, but I'm going to go do one more thing just while we're on this topic of profligate waste, because I'm passionate about it. The UK energy economy works like this. I know that, again, we can debate this a little bit, but run with me. 55% of all energy used to generate electricity in the UK is lost as waste heat. That's about 55%. That's worth about £22 billion a year. Is that recognizable? Because it sounds to me like the, so to speak, black hole in Rachel Reeves' budget. Of that, 15% is attributable to the UK government, which is about £3 billion. That number is twice what they took off the winter fuel allowance for pensioners. So I think this is the wake-up call. It is a thought bubble that needs to burst. It's not just how we think about energy, but it's how we think about waste. I don't know we haven't spoken about this. The budget was this week. Personally, I don't mind paying a little bit more tax. What I mind is it being wasted. So I'm very interested in what happens next on the reform side in this country. But what we've got to see, not just here, there's obviously the Doge, Elon Musk movement in the United States for efficiency. But what we actually do now need to see is that money is put to work well, and we don't just waste it.
And I think the worry in terms of waste is that figure of 55% and so on. I mean, if we go to 100% clean electricity by 2030, which is the pledge of the government, I don't think it'll be 100, but even if it's 95% or whatever, then most of that will have gone away, that waste, because we will no longer, by definition, be doing unabated gas generation. But the waste could be enormous amounts of curtailment of that offshore wind and the renewable electricity in the north. So we'll still have waste. It'll just look different. But I want to come back to data centers, because if we look at big developments since you and I last sat in the hot seats here, data centers, AI. I'm just writing something for Bloomberg. We'll do the audio blog version here as well on the year that AI woke up to energy and energy woke up to AI. Yeah. Data centers are not now your dad's or even your older siblings' data centers. I mean, we're talking about Microsoft and OpenAI are talking about 5 gigawatts of data centers, presumably somewhat distributed, not all in one location. Others are talking about trying to do 1 gigawatt, 2 gigawatts in one location. None of that's going to happen in West London, surely. But what is happening with data centers and AI in your world?
10 years ago, you're right. We started developing on-site power and energy efficiency solutions for data centers, for what they call enterprise data centers.
How big were they?
2 to 10 megawatts. It's still pretty significant. Just putting things into context, even a 210 megawatt facility is pretty substantial. Yeah. Right. And that's the sort of thing that you'd see in anything from a small cloud computing to a sort of enterprise data center for a bank. Okay, so what's happening now? The data center systems that we're serving, minimum 100 megawatts for any kind of relevance, 300, 500 megawatts for a decent availability or mega zone, a gigawatt announcements coming out of the big hyperscalers. So these things are getting bigger, and that's for, let's call it the more traditional computing or cloud storage now. AI will take that to another order of magnitude. Now, we can debate the pace and sustainability of the growth of AI, but the power density is enormous. So, whereas I would say my own experience in the data center sector is that we've seen about an order of magnitude increase in the scale of data centers over the last decade, there is another perspective order of magnitude increase, not just with the organic growth of the sector, but also, of course, the advent of supercomputing and AI. So what I would say is very large amounts of power density, big problem, not just on availability of electricity, but also other things like water.
I think you put your finger on it when you said power density, because for these, particularly for machine learning, you need to get loads and loads of GPUs, an accelerator. It's not just a single chip; it's now a whole system on which it runs, and you need to get tens and then hundreds of thousands, possibly ultimately even millions, into one location. And power, and of course, everybody would like to do that with clean electricity, green if possible. But that's really, really hard. And so they're talking about using nuclear power. Yeah. And the reason is the amount that you need concentrated into one location, and it needs to be dispatchable. I mean, you can't spend 12 billion on a data center and then say, well, I'm only going to use it when it's sunny.
Actually, it needs to, I think what you mean is it needs to be constant. It needs to be available 24/7, 365 days a year. In fact, data centers typically, AI is a little different, but data centers typically operate on a 99.999, what they call 5 nines availability.
There is a debate about, by the way, and EPRI, the Electric Power Research Institute, has got an initiative called DC Flex, Data Center Flex, saying, well, do you know what? This stuff might just be too hard to have it running at 5 nines flat out. Too hard for the grid, too hard for the supply. So maybe data centers need to play nicely with the supply,
or network with themselves,
and then flex up and down and so on. But how do we solve this with clean electric? Because my worry is that it's so hard. And by the way, my worry is also that the nuclear will end up proving too expensive. And so that the AI industry will say, do you know what? We're delivering so many benefits through AI, optimizing this, optimizing that, saving energy elsewhere in the economy. Let us just use gas.
A lot of it, I think, obviously, apart from, we talked about growth of renewable power, actually, the big software companies have been a big part of that. They've been stepped into the role of government, really, buying power purchase agreements, buying renewable energy offtake for the last 5-10 years, right? The biggest buyers in the world. But it's a financial, in the end of the day, if you don't mind me saying this, it's a bit more like a financial product. I'm using energy over here and I'm going to buy renewable power over there. I think what the new locational solutions is a bit more like what we've been talking about today, edge, that is distributed generation. So you're talking about real electrons and real molecules, and how
actually powering the data center
and not
the
just
data center. Buying, not just funding some wind and solar in India, which is in the middle of the night, and then saying my data center in Nevada is now clean.
Yeah. So I think actually that's probably one of the biggest changes, which is, I think the data center market is starting to really look at how you get physical energy there.
Well, so it's very interesting. In fact, certainly Google and Microsoft are absolutely trying to match temporally and locationally. So they actually power the data centers with meaningful clean electricity, but the rest of the tech titans are much less convinced. They're not as enthusiastic, let me put it that way.
So, if you're looking at sort of where I think this is going, I think there's going to be a lot more focus on site or near or adjacent site energy generation power. And I also think the other thing that's where it's going, there's a factor called the PUE, the power usage effectiveness. And I think on that side, you're going to see a very, very significant focus and step change on the efficiency of supply.
But the PUE for big new data centers is already, as good as 1.1. In other words, the actual computing, the PUE is the ratio of total energy used on site to the energy used by the servers and computing. Yeah. It's already 1.1 in that's the sort of best practice. So yes, there's some catching up, But I just worry about this because, meanwhile, you and I, we love this stuff and we'd like to be enthusiastic and we're generally optimistic. Meanwhile, Elon Musk is building the world's fastest supercomputer using whatever it is, 100,000 NVIDIA GPUs, and he's building diesel gensets to power it because it's just the quickest way to do it and speed matters and therefore diesel gensets. How do we make that not happen?
One of the dirty secrets of the data center market is that pretty much all data centers, with a few exceptions, like one I helped Microsoft deliver, run on backup power. Backup power is from diesel.
Yeah, backup is very, there are other things you can do, possibly even, by the way, hydrogen, but backup hopefully is not used very much.
So go back to the point, with difference in the way the world could work or that we'd like it to and the way that it does. So I'm just going to focus for a second on the way that it does. So diesel at the moment is the stalwart of backup for data centers. It's filthy. You need to run it 400 hours a year just to test it. So one of the ways that you could decarbonize data centers is switching from diesel. And there are better ways to do it, even using nat gas. The second thing, when you come to PUE, you're saying that the best ones are 1.1 or 1.09. Two things, one of which is let's just keep going because that still implies that 10% of the energy that's going in isn't coming out as compute. The second thing is actually most of them aren't. There's somewhere between 1.4 and 1.5. So that's the way the world is, not the way that we want it to be. And I think I'm seeing a lot of, I'm being optimistic, a lot of innovation in how we can improve because that difference is really about cooling. You put the power into the building. You're putting the juice into the racks, but you're putting a lot of electricity goes to cool the data center. I've seen fantastic movement in changing the way that these buildings work. So rather than, for example, cooling the room, instead focus on cooling the rack, the computer itself, or even the chip.
The chip, liquid to chip.
So that's exciting, and we've seen all sorts of liquid cooling, precision immersion, precision liquid cooling solutions. And, I went to visit one actually recently, which is amazing in Bologna. It's called Leonardo. It's the European Commission supercomputer for climate and pandemic modeling. You go into the room, it's warm. It's liquid cooled. I think the PUE was about 1.09. It's NVIDIA chip. By the way, it's the most amazing spiritual place to be because you've got this massive supercomputer being asked questions by 250 people. All at the same time. And it's extraordinary, but the power density is completely different. It's 8 to 10 times as dense. So just going back to what we were saying before, data centers together with hospitals, by the way, are typically the biggest energy users in any economy. But data centers are growing very fast. And there's another feature, which I'd just like to touch on, which is the way that hospitals, healthcare, and defense, so in other words, the two biggest parts of the public sector, are going. A very large proportion of their energy use is going to go on data centers too. So, you're going to see this isn't just about the traditional commercial industrial applications. I think we're going to see, the fusion together of commercial industrial together with public data. And that's just driving a very substantial growth. So you add that growth together, and then you think about what it looks like if it's an order of magnitude bigger. And that's why there's so much focus on data centers. We're
going to leave data centers there because there will be this upcoming episode, deep dive. I'll just say that Leonardo will look like a sort of, I don't know how to put it, a Model T Ford compared to I don't want to say a Tesla. I'm grappling a little bit, but it's going to look old-fashioned pretty darn quickly is where we're going. So I agree with you, and it does require that focus. Just before we finish, I want to do a quick tour of the horizon of the big policy areas. Yes. When we last had you on the show, we talked about the US Inflation Reduction Act. We talked about the EU Green Deal. And very exciting initiative here in the UK called the Energy Efficiency Task Force, on which I sat.
Yes.
Until it was yanked by the previous Sunak government. Now I was trying to get you to be negative about the Inflation Reduction Act and the Green Deal because it was only putting energy efficiency onto the board. It was only just sort of raising, it was allocating 15, 20% of investment on the energy efficiency side when we've both agreed that it needs to be 50% or more. But you resisted the urge to be negative, and you said, "Look, it's fantastic." And but where are you? Have they fulfilled even that promise, or have they been big disappointments? Where are you?
All right. So I think we've now got the benefit of a bit of hindsight since we had those discussions, because the Inflation Reduction Act was quite new. The European Commission had launched many, many different programs for about €1 trillion actually of stimulus this decade. So if I look at, so I set up Sustainable Development Capital 17 years ago. If I look at the last 15 years, do you know how much the European economy has grown in GDP terms?
Doubled.
10%.
Sorry.
Yeah, exactly. Wait.
Oh, what? Sorry, we're talking Europe. Oh, of course.
In US
stagnant
terms,
old Europe.
Right.
Yes.
Do you know how much America's grown?
Probably nearly. Well, 80, no, it's probably 80%. 70%.
You're very good at this. 82% or just over 80%.
Wow.
And where are we on the physics, the energy physics of that, right? What's happened over the last 5 years? Energy in America, energy independence really is quietly declared in America, right? Coming back to Europe, is there a thought bubble, right? So where's all the money going to go? Where's this €1 trillion going to be invested? So I just want to come back to this point about, I'm not being negative about Europe, I'm being positive that, but can Europe be energy independent? And I think just to give you some ideas about the interlink with the US, gas imports from the United States to Europe have gone up 3 times in the last 5 or 6 years. And overall energy has gone up about 50% in terms of imports from the United States. So what can Europe do when its gas is 6 times higher and its electricity is 2 times higher? It can start to look at efficiency. It can look at competitiveness and productivity. So just as we're trying to invest in producing energy locally through renewable sources, at least as much has to go on, and it's starting to get through in Europe, but very, very slowly. So that's what's happening. The bit that makes me really excited is that everybody talks about the Inflation Reduction Act, to come on to a second, but there's huge capital from the European Commission and related parties for the European nexus. It's about $750 billion yet to spend between here and the end of the decade.
But you came on the show beginning of 2023 and said there was nearly $1 trillion. And so are you saying it has still not flowed yet? It was building efficiency. We talked about the building regulations.
About a third of it. But I think we're going to come on to the Inflation Reduction Act, but all of the attention goes on to the Inflation Reduction in the US. I'm just bringing us back into the European. I'm actually quite optimistic. I don't want to bash it. I just don't think that there's enough going on in Europe to focus on where the big change can happen, because I think generating renewable power, or even, all the money that's going into hydrogen is all very well, but we need to have step changes in the next 2 to 3 to 4 years.
One of the things that I think is happening is that, this sort of post-cheap Russian gas period, and it led to the Green Deal, but also, in Europe, people were just grasping onto hydrogen, thinking that it would drive competitiveness, thinking it would drive job creation, thinking it would drive exports. And I think that souffle is now deflating, which means hopefully we'll get a bit more attention on what does the EU do to avoid deindustrialization. The EU, Europe is a high energy location. It just is. Well, it has to live with that.
A high energy use location.
High energy cost.
Yeah, absolutely.
Sorry, it's a high energy cost location.
Yeah, it is. And, you opened this session by saying this is boring. I think competitiveness, productivity, and making Europe win by being more competitive, more productive, more efficient is exciting. Right. Now, coming on to the United States, the Inflation Reduction Act, a lot of the money is being pushed out of the door. There may be or may not be a significant change of regime, but either way, there's still built into the US economy a few really interesting factors. Number one, clean energy is relatively cheap to build in the United States. It is competitive. America is a global energy titan. Whichever, whether it's Republicans or Democrats, there are things that bind people together. First of all, Republican states love how much money is going into. 18 letters went into the Congress recently from Republican states saying how happy they were that clean power is being generated in those states.
Probably not enough, though, to make them actually to change their voting intentions, right?
I don't think their voting intentions really need to change. I got lambasted for saying that the change of regime wouldn't really matter. I think there's enough going on the ground to generate renewable power momentum still. There are going to be areas of the market that are incredibly vulnerable. Offshore wind, anything that's expensive and just produces. But, there's a lot of ways in which renewable power can compete. But the big area which I'm really excited about, passionate about, it's the same as the opportunity that Europe have. If America can take the opportunity to stop wasting so much energy consumption by the US consumer in the US is about $1.7 trillion a year, right? It's 6-7% of GDP. If so much of that is being wasted, Michael, either at the end use or on the supply side, we're talking trillions, literally 5-6% of GDP. And that is a massive opportunity for the US. So I think the Inflation Reduction Act is great, but it's a $26 trillion economy. And we're talking about maybe 300 billion, maybe $1 trillion dollars rather. So if we think about the big picture, the big money, the big competitiveness can come by being more efficient and competitive.
I want to leave with one final thought, because we've did the EU, where, so money's starting to flow, but basically EU still has an energy waste problem and an energy cost problem. And then we talked about the US, where money is flowing because of the IRA, the Inflation Reduction Act, but it still has, at the very least, an energy waste problem, if not an energy cost problem, right? Meanwhile, the one that you didn't touch on is China. What is China doing? And I want to show you this. We'll put a version of this, we'll cut it into the video for those watching on video, and we'll link in the show notes for those on the podcast. But what this is a share of final energy from electricity, China versus the US and Europe. And coming back to your point about, the electricity is such a small part of the economy, that's true. And look at Europe and the US. It has essentially stalled at 20%. Go back to the 1970s, it was 10%. Now it's 20%, but it's stalled. And China, based on this chart, it's not an endorsement of their politics, but let me be very clear. But based on this chart, China gets it. China is nearly at 30% electricity, right? And that is the way, because it's more efficient, even if it's coal or gas, but especially since we know that China is, installing solar and wind at such an enormous rate. That is energy that goes straight to electricity. There is none of that waste. They get it and they're forging ahead and they're creating the technologies around it. So isn't the big picture story here is that we need to wake up to that, do we not?
So absolutely we do. You asked about ESG, right? ESG was a movement. It started really in Who Cares Wins 2004 from the UN. And then there were the Principles of Responsible Investment in 2006. We mean really well in the West. But China's been getting on with it since 2006. When we were producing the Principles for Responsible Investment, the medium-term economic plan, the 11th five-year plan was being printed in China. They knew exactly what they were doing, but it was competitiveness, it's a productivity, it's efficiency, it's effectiveness, and it's growth. And that's what China's been investing in. It's what China's thought through. It's thought over the long term. So when we think about these things here in Europe or we think in America, we need to think strategically, and we need to think like take this leaf out of the Chinese book. What's the problem we're trying to solve? What are our resources and how can we make them work better for ourselves?
As you were speaking, I was thinking, so what you're saying is that China has done the right thing for the wrong reasons, possibly wrong reasons, whereas we've been doing the wrong thing for the right reasons.
I think we mean well, now it's time to do well.
We mean well, now we have to do well. Jonathan, it's always a pleasure. Thank you so much for joining us here today.
Thank you.
So that was Jonathan Maxwell, CEO and founder of Sustainable Development Capital LLP, back for his third appearance on Cleaning Up. And, as always, we'll put links in the show notes to resources that we mentioned during the episode. And that was episode 14, Cheaper, Cleaner, More Reliable, all the way back in October 2020 when Jonathan first came on the show. Episode 113, the checkpoint on energy efficiency in January 2023. The audio blog of my Superheroes of the Net Zero Transition piece, which is audio blog 12, in which I explain the primary energy fallacy in great detail, and episode 160, Dr. Ma Jun, member of the Monetary Policy Committee of the People's Bank of China, talking about how China became a green finance superpower. With that, I'd like to thank the whole production team, and we'll see you in a week's time for another episode of Cleaning Up. Cleaning Up is brought to you by the members of our leadership circle. That is Actis, Ecopragma Capital, EDP of Portugal, Euroelectric, the Gilardini Foundation, KKR, National Grid, Octopus Energy, Quadrature Climate Foundation, SDCL, and Wärtsilä. For more information on the Leadership Circle, please visit cleaningup.live. That's cleaningup.live. If you're enjoying Cleaning Up, please make sure that you subscribe on YouTube or your favorite podcast platform and leave us a review. That really helps other people to find us. Please recommend Cleaning Up to your friends and colleagues and sign up for our free newsletter at cleaninguppod.substack.com. That's cleaninguppod.substack.com.